Now in this session we are going to see the elastic properties, types of modulus and Poisson's ratio. Now what are the types of modulus? Young's modulus. Y. Longitudinal stress by linear strain. It is a ratio of longitudinal stress to the linear strain. Young's modulus within the elastic limits. So Y is equal to longitudinal stress by linear strain F by A by X by L, that is FL by AX. Next is bulk modulus, which is shown in liquids. Bulk modulus is K, compressive or volume stress or pressure per volume strain. It is a ratio of compressive stress to the volume strain, which is shown in the liquids. It is force per unit area by change in volume to the original volume. So if you do this, force per unit area is nothing but the pressure. So PV by change in the volume. So PV by small v, without the change in the shape of the body within the elastic limit. That means bulk modulus is it is a ratio of compressive stress to the volume strain without change in the shape of the body within the elastic limit. Next is the rigidity modulus. Rigidity modulus is denoted by eta, tangential stress by shearing strain. That is force per unit area by shearing strain is X by L. So it becomes FL by AX. But we know that force per unit area by X by L becomes nothing but a theta. It is nothing but a shearing strain. So we call rigidity modulus as F by A by theta, where theta is called as a shearing strain. Next we see the longitudinal strain coefficient denoted by alpha. Longitudinal strain produced per unit stress. That is longitudinal strain is equal to X by L. That is extension produced. Longitudinal strain is nothing but the change in length by original length. Change in length is X, original length is capital L. So longitudinal strain is X by L. Longitudinal strain or for T is the applied stress. So it becomes X by L. Further, that means X by L is the longitudinal strain for the tension T applied stress. So alpha is defined as longitudinal strain produced per unit stress. So alpha is defined as X by L by T. So it becomes X by TL, or alpha is equal to X by TL, or X is equal to TL into alpha. Next is a lateral change. If there is a change which occurs perpendicular to the direction along which deforming force is acting, is called as a lateral change. That means if there is a change occurs perpendicular to the direction along which the deforming force is acting, is called as a lateral change. Now I can tell you an example of this. Consider a rubber band of having a length L. When you apply a force along its length, the diameter of the rubber band, that means the thickness of the diameter of the rubber band, reduces. Such type of a change is called as a lateral change. That means when the change is occurring perpendicular to the direction of the application of the force. When the length is for a rubber band, if you pull with your hands from left to right, if you keep on increasing the length both sides, left and right, the diameter of the rubber band reduces. So the change is occurring, diameter is along perpendicular to the application of the force. So the force is applying, you are giving along x-axis, and the change is occurring along the y-axis. So it is called as a lateral change. Now lateral strain is if deforming force acting on a wire assumed to have a cross-sectional area produces a change d in its diameter when the original diameter is capital D, then that is called as a lateral strain, small d by capital D. It is a contraction. Lateral strain coefficient beta is a lateral strain produced per unit stress is beta. So lateral strain coefficient is denoted by beta. Lateral strain produced per unit stress. So T by D by T into D. T is nothing but the stress and D is the original diameter. Next is a Poisson's ratio. It is denoted by sigma. Within the elastic limits of a body, the ratio of lateral strain to the longitudinal strain is constant. That is, Poisson's ratio is defined as a ratio of lateral strain to the longitudinal strain. That is, lateral strain is nothing but small d by capital D, and longitudinal strain is X by L. So if you take that, it is dl by xt. This is equation 1, which relates change in length and the diameter gives the lateral strain to the longitudinal strain. The relation between alpha, beta and gamma. Relation between sigma, alpha and beta. Sigma is the Poisson's ratio and alpha is the longitudinal strain coefficient and beta is the lateral strain coefficients. Now if you see, we know that alpha is equal to x by TL and beta is equal to d by TD. So beta by alpha gives you d by TD into TL by x. That implies TT gets cancelled. So it is capital LD by x into d. We know that from the equation 1, we know that dl by xd is nothing but sigma. Therefore, sigma Poisson's ratio is defined as beta by alpha, that is lateral strain by longitudinal strain coefficients, since sigma is equal to LD by XD. So, this is a relation between sigma Poisson's ratio, lateral strain coefficient and longitudinal strain coefficient. Next, we see the expressions for y, k and n in terms of alpha and beta. What is y? Young's modulus. K is the bulk modulus. Eta is the rigidity modulus in terms of longitudinal strain coefficient and the lateral strain coefficients. Now, what is y? These are the three equations which we are going to derive. First one we will see y is equal to 1 by alpha. Y is Young's modulus and longitudinal strain. We see the proof now. We know that Young's modulus is longitudinal strain by longitudinal stress by longitudinal strain. So y is equal to stress is F by A and x by L becomes a longitudinal strain. So F by A is nothing but T x. So if we have given as x is equal to T L into alpha. Substituting the terms here, F by A is capital T, that is force per unit area is nothing but the stress. So we are writing as T, and x, we are replacing x as TL alpha, substituting that value x T L alpha by L, LL gets cancelled. So T by T alpha, which is nothing but 1 by alpha. So y is equal to 1 by alpha. It has been proved. Now relation. See, in this equation, the second k is equal to 1 by 3 into alpha minus 2 beta. I have made a separate video for the derivations of the second. K is equal to 1 by 3 into alpha minus 2 beta. And third equation, eta is equal to 1 by 2 into alpha plus beta. These two derivations, I made a separate videos for these two. Okay. Next, relation between y, k and n. Y is Young's modulus, eta rigidity modulus and k is the bulk modulus. Now, if you see the relation, k is equal to 1 by 3 into alpha minus 2 beta. If you see here, from the denominator, remove alpha as a common factor. So, 1 by 3 alpha is removed. It becomes 1 by 3 alpha into 1 minus 2 beta by alpha. So, what is meant coming 1 by 3 alpha into 1 we know that beta by alpha is nothing but the Poisson's ratio. So, in the denominator, I write it as beta by alpha as Poisson's ratio. So, the equation becomes 1 by 3 alpha into 1 minus 2 sigma. So, that becomes, if you take it, rearranging the terms, 1 minus 2 sigma is equal to y by 3k. This is equation 1. How we can do this is, we know that 1 by alpha is nothing but y, which we have derived earlier. So, from this equation, I have taken as 1 by alpha is directly I am writing as y. So, the equation 1 has coming into picture here. Now, similarly, we go with eta is equal to 1 by 2 into alpha plus beta. Taking alpha in the denominator common, 1 by 2 alpha is equal to 1 plus beta by alpha. That is 1 by 2 alpha into, we know that beta by alpha is nothing but sigma. So, I replace beta by alpha as sigma into this equation. Rearranging the terms, also we know that 1 by alpha is nothing but y. So, I have written here as 1 by alpha as directly y. So, 2 plus 2 sigma is equal to y by eta, which gives the equation 2. So, adding 1 and 2, if you look at this equation, adding 1 and 2, 2 plus 1 is 3, 3 is equal to y by 3k plus y by eta. Rearranging and taking the LCM, you are getting the y is equal to 9nk by eta plus 3k, or 3 by y is equal to 1 by 3k plus 1 by eta. This is a relation between y, k and n. Next, what are the limiting values of sigma? From equation 1 and 2. That means from equation 1 and 2 from this slide. So you see here there are two equations 1 and 2. What we can say here is equating the values of y. Take the values of y, take the 3k to the other side. Equating the values of y, you are getting 2n is equal to 1 plus sigma and 3k is equal to 1 minus 2 sigma. If sigma is positive, in this equation, if sigma is positive, LHS is positive, but RHS to be positive, sigma must be less than 0.5. That means sigma is less than 0.5. If RHS is negative, that means, or if sigma is negative, RHS is positive, but LHS to be positive, sigma must be greater than -1. That means sigma should be greater than -1 and it should be less than 0.5. So Poisson's ratio, the limiting values are sigma should lie between -1, should be less than -1 and should be less than 0.5. So it lies between -1 and 0.5. Thank you.